Okay, in the last lesson, we looked at measures of dispersion. So we were looking at an entire set of data, for example, all of the test scores for Unit 1 in this class, and looking at how spread out that data was. With this lesson, we're going to be looking at individuals and comparing individual test scores to the mean and the standard deviation. So normal distribution is where this comes from. And normal distribution is a bell curve that shows how data is distributed from the mean. When I went to college, all of my professors used a bell curve. So they found the mean on the test, okay, and that's right here. Okay, remember a symbol for mean is mu, and then our calculator also uses x bar. So we have two different symbols for mean. Then they calculated the standard deviation, which we learned how to do using our graphic calculator in the last lesson. And they said that about 68% of the data, all of this here in purple, 34% of the class should be one standard deviation below the mean, and 34% of the class should be one standard deviation above the mean. So now we have two standard deviations above or below, and we've got what? 68 plus 27. So 95% of the data falls within two standard deviations. So 95% of the class has to fall there. And within three standard deviations, we pick up another 4%, and that's 99% of the class. And only 0.5% should be above that. So here's what my professors did. C's, B's, A's, D's, F's. It was very, very, very hard to get an A unless your grade was a lot better than everybody else's in the class. On the flip side, it was very, very hard to get an F unless your grade was a lot worse than everybody else's in your class. Didn't matter how much you knew. What mattered was how you compared to your classmates. Fortunately, we don't grade that way anymore, at least not in high school. There are still some college professors that grade that way. So let's take a look at an example. The grades on a statistics midterm are normally distributed with a mean of 81 and a standard deviation of 5. So let's sketch our bell curve. 1, 2, 3. 1, 2, 3. Okay, our mean is 81. Goes right here in the middle. Now, plus 1 standard deviation. Since our standard deviation is 5, that means 81 plus 5 is 86. Up 2 standard deviations, 86 plus 5 would be a 91. And up 3 standard deviations, 91 plus 5 would be a 96. Now let's go down. Down 1 standard deviation, 81 minus 5 is 76. Minus a second standard deviation, 76 minus 5 is 71. And down a third standard deviation, 71 minus 5 is 66. Keep in mind that this should be about 34% of the class and 34% of the class for a total of 68. Then we go down by about 13.5%. Then we go down another 2%. And this is only about 0.5%. 0.5, not 0.05. Okay, what percent of the data falls between 76 and 86? Another way to ask this would be what percent of the data falls within one standard deviation? 76 to 86. So that's going to be 68%. What percent of the data falls between 71 and 91? Well, another way to say that would be what percent of the data falls within two standard deviations. Right? So we have 68 plus 27 again, which is 95%. What percent of the data falls between 81 and 91? Ooh, another way to say this would be within two positive standard deviations. We're only interested in 81 up to 91. So 34 plus 13.5 is 47.5%. And what percent of the data is less than an 86? Whew, a lot, right? That means I have to start here at one standard deviation and go all the way down, and that adds up to about 84%, if I've done my addition correctly. Okay, so we have this distribution using standard deviation. How do I use it to compare individual scores? To do that, I use a z-score. It is a score that shows how many deviations, a data value, standard deviations, one data value is from the mean. If I think back to the example we just did, and I'm even going to go back and look at it here, right? If these are my test scores, well, I want to be 2 or 3 standard deviations above the mean. I want to have a z-score that comes out as a positive high number because I want to be better than everybody else in class. I definitely don't want a negative z-score. That would mean I did worse than everyone else in class. Okay, whether you want a positive or a negative z-score depends on the context of your problem. So if we were looking at where you fell in terms of catching the flu, you want to be on the negative side because you want to be slower than everyone else to catch the flu. But when it comes to test scores, definitely positive. Now, as we look at all of these, Z stands for z-score. That's really nice, right? X is the data point. Mu is the mean. And of course, sigma is standard deviation. So we can get the mean and the standard deviation of our calculator. Actually finding the z-score, we have to use the formula. But the formula is on the SWIL formula chart, so you do not have to memorize it. Let's take a look here. The grades on the statistics midterm are normally distributed with a mean of 81. So mu equals 81. At a standard deviation of 5. So sigma equals 5. Find the z-scores. So z is going to be equal our data point, in this case 65, minus the mean, divided by the standard deviation. So 65 minus 81, enter, divided by 5, enter, negative 3.2. Did this person do really well on the midterm or really badly on the midterm compared to the rest of their classmates? And the answer is really, really, really badly. They're all the way down there in that negative 0.05% on the far, far, far left part of the bell curve. Not a good score. Next up, Z equals our data point 83 minus our mean 81 divided by 5. 83 minus 81 enter, divided by 5 enter, 0.4. Okay, a little above the mean, but really close to it. And that makes sense, right? 83 is above 81, it's greater than 81, but it's pretty close to 81. Last person here. Perfect score minus the class average divided by the standard deviation. And we have a z-score of 3.8. This is the person I want to be. I want to have a z-score well above the class because I want to be outperforming everyone else. All right, let's do another one. This data represents the heights in inches of the Greenwood High basketball team members. Find the z-scores for each of the following. Hold on, we need the mean and we need the standard deviation, which means I need my graphing calculator because I can't do that in my head. Stat. Edit. Clear it. And clear it from the last time I used it. Okay, lots of numbers to put in, huh? 76, 66, 67, 69, 73, 74, 72, 71, 75, 69, 72, 70, 78, 70, 71, 73. Let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, I entered the correct number of values. Very important to check. Stat, help, 1 variable stats. I need list 1. Calculator magic. My mean is 71.625. So mu, 71.625. Standard deviation, 3.0999. Right? Well, let's plug in some values here. Z equals this person's height minus the team average divided by the standard deviation on the team. And I'm just going to pick up my handheld calculator for this one. 66 minus 71.625, enter, divided by 3.0999, enter, negative 1.8146. So he's more than 1 standard deviation below the mean. He's pretty short compared to the rest of the kids on the team. Z equals the height of this player minus the team average divided by the standard deviation. 73 minus 71.625, enter, divided by 3.0999, enter, 0.4436. So a little above the standard deviation, but pretty close to it. And the last one, 80 minus 71.625 divided by 3.0999. 80 minus 71.625, enter, divided by 3.0999, enter. Oh, 2.7017. So almost 3 full standard deviations above the mean. So much taller than everyone else. Let's look at another example here. Data represents the scores in a certain class on the Unit 8 test. Find the z-scores. Oh my goodness. Alrighty, well, gotta find that mean and gotta find that standard deviation. So stat. Tell the smartboard to stop writing. Stat. Edit. Arrow to the header. Clear enter to clear out the last set. And we're putting in 48, 192. 100, 92, 92, 84, 68, 84, 92, 52, 56, 88, 62, 58, 80, 84, 44, 88, 80, 68, 96, 88, 72, and 80. Now this L126 at the very bottom means I have 25 pieces of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5. Yes. Stat. Tell. One variable. It's on list 1. Calculate. Calculator magic. My mean is 77.92. Okay, so the class average is C+, and the standard deviation, 16.2528. That's a pretty big standard deviation. That tells me people were all over the place with these test grades. And if I look at it, I've got a 44 and a 48, that's horribly low. You know that I won't let you get away with that. I'll make you redo it. And then I've got 100 and a 92 and another 100, so I've got some really high scores also. Let's look at these 44s. Our z-score for the 44 will be, substitute your values. So, using my handheld calculator. Negative 2.0870. So 2 full standard deviations below the class average. Not good. Let's look at the 68. I'm going to put it down here, approximately negative 0.6104. So almost a full standard deviation below, but not as bad as that 44. Let's take a look at how the 96 did. 96 minus the mean divided by the standard deviation. So 1.1124. So this person was a little more than a full standard deviation above the mean. Let's look at another set of examples. The The z-scores of 4 students on a particular algebra test are given below. Ooh, the mean of the test was 85. Mean 85. And the standard deviation was 4. Find each student's test grade. I love to do this to students, and I've been known to do this to students in my day school after they've learned z-scores. Okay, so I'm going to take my formula, z equals the data point minus the mean divided by standard deviation, and I'm going to plug in the z-score for Zach. Negative 0.75 will equal his test grade minus the class average divided by the standard deviation. Now to solve this, I need to use my algebra skills. I'm going to multiply both sides by 4, so negative 0.75 times 4, and then I need to add the 85. And his score is an 82. Now what did I just do in my head? I multiplied both sides by 4, and I got negative 3 equals x minus 85. Then I added the 85, and his test score was an 82. Okay, so let's look at Taylor. Z-score of 3 has to equal his test score minus 85 divided by 4. So 3 times 4, and then add the 85. That's a 97 for Taylor. Let's look at Ross. Negative 2.5 equals his test minus the class average divided by the standard deviation. So negative 2.5 times 4 plus 85, he got a 75. And finally, Natalie, 1.25 equals test score minus 85 divided by 4. 1.25 times 4 plus the 85. Natalie got a 90%. All right, you've got some practice to work on.